All across the federal government, major spending cuts have been taking place. These have fundamentally reshaped how the government has been working and what the priorities and how we interpret those priorities have been landing, especially for researchers and scientists. Now, this impacts, of course, science and the way that we learn and grow across universities and corporate researchers, but also it has real immediate impacts on how we understand the world around us, not just in opaque terms or in theoretical ones, but in things as mundane as our weather forecasts. So today we're sitting down with three different experts in our area to talk through the way that federal spending cuts, and especially those cuts to science, have been impacting how we understand our world, first from a climate standpoint, and then at the very local level of interpreting weather data and what it means going forward for getting information that varies from understanding the risks to our local lived environs, thinking about things like hurricanes, droughts, and floods, all the way down to just the simple things like, will it rain tomorrow? I'm Weston Twardowski, the Associate Director of Rice's Center for Environmental Studies and Associate Director of the Eco Studio in Rice's Sustainability Institute, and you're listening to Gulf Streams on KPFT Houston 90.1 FM, Galveston 89.5 FM, and Huntsville 89.7 FM, where we talk with leading experts and community leaders to better understand the environmental problems and potential solutions facing our community. A quick reminder that you can catch up on Gulf Streams anytime through our podcast, available on all major podcast platforms. If you enjoy the show, please like and subscribe to make sure you never miss an episode. First up today, we're speaking with Andrew Hoffman. Dr. Andrew Hoffman is a postdoctoral research scientist in marine and polar geophysics at Columbia Climate School, and my researcher, Antara, is joining me as well today, and we are delighted to get to sit down with you and talk through and think through a little bit how climate research gets done and what government funding pattern shifting really means in this moment, which is understandably rather unpredictable, but we want to think through that a little bit, just having a bit of an appreciation of how is climate research changing right now. So with that, Antara, I think you're starting off.
Yeah, just to start us off, welcome to the show, first of all. So happy to have
Thank you.
Could you introduce yourself and a little bit of the work you do?
Yeah, my name's Andrew Hoffman again. My formal training is as an undergrad was in math and physics, and so I use equations, also technologies, primarily radar, as a method that we can use to understand and image the end glacial structure of ice sheets. So by measuring how ice sheets are changing over time, with this technology we can understand and predict initialized models that we need to understand future contributions to sea level.
And this is all kind of under the umbrella of climate research, if I'm correct, right?
Yeah, so the cryosphere is in which ice sheets are one component of the cryosphere, is one component of the larger Earth system that we aim to study as Earth scientists and climate scientists. So ice sheets have changed dramatically in size and configuration over thousands of years, and so understanding their role in the climate today is really important if we want to understand, and also understanding their role in climate in the past. Both are important to understanding how sea level and the global climate system will change in the future.
And then at the risk of dipping into nerdiness, what does it really mean to study ice sheets? What are some of the parameters you're looking for? Are there trends that you're looking to identify?
Yeah, so my research focuses on understanding and parameterizing how viscous ice is as a material, as a fluid, and how rigid or resistive the bed of the ice sheet is. And so those two kind of parameters control how ice flows and slides, and control also how the ice sheet responds to climate. So as the poles warm, ice sheets, accumulation that falls at the surface of the ice sheet changes in time. And essentially, you can think of the ice sheet itself as this filter, filtering out how much snow that's deposited at its surface reaches the ocean. And so the conveying efficiency of the ice sheet, if you want to think of it as a conveyor belt, is kind of the focus of my research.
So what does that look like in practice? Because I think this is something that folks really struggle with, is to kind of understand. I think to some degree, if you say chemistry, we kind of jump back in time to high school and we go, right, I had a Bunsen burner and, I had some things that I played with, and that feels very tangible. What does climate research, and I mean, speaking from your own experience, are you taking ice core samples? Is this all being done with satellites? I mean, how does this actually work and get reflected into the work that you're doing? Because I think those are questions folks don't really understand about. I know I certainly struggle with understanding what this actually looks like in practice.
Yeah, I jokingly tell people that I did my graduate studies. I did them at the University of Washington, but my degree is really in packing boxes, because a huge part of doing field work in particular is packing supplies and equipment, not just for the research that you're going to conduct, but also living in these climates or these polar regions, wherever you're working to conduct the field work. So a huge part of my work is preparing field teams, making sure people feel safe, making sure that people have all of the gear and equipment that they need to be comfortable in order to then conduct the science as part of a larger team, and then coming home safely as well. So a lot of it is connected to support and planning that happens before a field season. And I'm speaking about field work, and that's one component of my research group. I also work a lot with remote sensing data sets. Combined, those are the two kind of the main the tools that I use in my research.
So switching a little bit to try to understand better, what I think, you say working in boxes, but I know that you are using, and you say field work. I mean, field work takes a great degree of going places, of being at, literally collecting samples, of doing this work on the ground. I know you are also using a lot of satellite data. I think with climate modeling, I know right now you're part of teams that, represent not only multiple universities, but multiple fields working together to really think across all these different kinds of metrics and try to really understand how our climate functions, how it's shifting. That requires an immense amount of coordination. That requires an immense amount of time. And so this is research that, a lot of people are really, really invested in, and it requires that kind of stability of knowing how you're going to be able to actually put together the teams that can answer some of these questions. And I think we're all aware funding, especially at the federal level right now, is going through a period of major shifts in terms of priorities, in terms of how it's being recognized and awarded. So can you walk us through a little bit, what has the landscape of funding shifts that have taken place over the last year and a half meant for the scientific community? I mean, you're one person, but also I think from a lot of different institutions and folks that elsewhere, how has this reshaped how science is working in this moment?
Yeah, I can talk a little bit about work in Antarctica first, and then I can kind of zoom out and talk about some other examples of centers and organizations that are doing research on behalf of all of us. Scientists, but also policymakers and stakeholders, anybody who's kind of invested in understanding our climate and weather. But first, I'll talk a little bit about Antarctic fieldwork. So to support Antarctic science, the NSF has built a program called the U.S. Antarctic Program, and this program supports hundreds of millions of dollars of science every year. But for every kind of $1 of science, there's about $2 spent on logistics, just getting folks and personnel to the polls. That budget's extremely small in comparison with all of the other, the support that's spent on the rest of the government. So, this is we're talking about a very small fraction of the total budget, but that can reveal really important questions. So the poles are warming faster than anywhere else on Earth. They also contain a climate archive that's represented by the ice sheet itself. When we collect ice core samples in Antarctica and Greenland, we can sample directly past atmospheres, which is a unique thing that we can't really do with any kind of other record on Earth. And so collecting these samples is really important. And it helps us understand climate today, but also millions of years ago in the past. So the impacts that have been, the impacts are felt slowly over time, but millions of dollars that isn't spent this year to support next year's science prevents kind of decades potentially of work from happening. Just because of all of the funds and support that's required to stage fuel, to stage resources, to bring in folks who are supporting building efforts across the continent, and this is all of the downstream impacts have been felt already, and then are meaning that most of the work that we're doing is connected to logistics currently in Antarctica, and that the science itself is, we're doing essentially what we can minimally support.
Yeah, and then I was just wanting to ask, so considering this is a national program, international? National?
This is a national program. More frequently, though, folks that I work with myself, we're appealing to agencies and programs that are outside of the United States. So this fall, I worked with folks at the British Antarctic Survey who were conducting fieldwork on the Antarctic Peninsula that wouldn't have been possible to conduct without their support.
Mm-hmm. And you kind of preempted my question a little bit, but I was going to ask, so considering it's a national program, is it still somewhat insulated from a lot of these funding changes, or is there still that anxiety of, okay, we have to write a grant this Wednesday and then another grant this Friday and then try to go to the National Science Foundation? Is that still like in the kind of realm of thought right now, or is it mostly fine?
Mostly, we just don't know. So programs, there were 80, almost 80 projects last year that were supposed to be supported by the U.S. Antarctic Program. And we received notice that several of these projects were being cut, not because of the science itself, but just because it went beyond the scope of support for this year. And that's not the fault of the NSF. It's not the fault of program managers or the scientists themselves. It just is a reflection of you can't do the same amount of work with fewer resources. And it's not just this year's work that will be affected by the current cuts to funding, but it'll be the kind of downstream impacts of having more people trying to do more work with fewer resources, essentially.
I know something that's been in the news, particularly of late. We've both been on some phone calls where folks are talking about, risks to data storage and risks to kind of long-term projects, is related to the National Center for Atmospheric Research. NCAR is the acronym folks might have seen bandied about, and that's getting potentially closed down. Folks aren't exactly sure what's happening at the moment. But can you talk a little bit about what NCAR is and why that matters in this space?
Yeah. So NCAR is a federally funded research and development center in Boulder, Colorado. It has a long history connected to kind of the first climate models that were developed by U.S. atmospheric scientists in collaboration with folks across the world to understand and predict weather and climate. It continues to be kind of the force, the backbone behind weather prediction and climate prediction in the U.S. And without NCAR, to be clear, we really don't know what's going to happen to these kinds of agencies. And I think the the uncertainty that's associated with that is already having downstream or consequences or effects for folks, researchers there, but also folks who depend on NCAR data sets and who are now downloading data frantically to try and make sure that these archives are preserved. But yeah, NCAR is as an institution, supports scientists here in the U.S. It supports scientists around the world because of model simulations that are too expensive for a single institution to run. And essentially, it exists as a portal, as a place to access these data, where the simulations that have been predefined by the community can be accessed in one central location.
Are there other institutes like this?
No, NCAR is quite unique, and so it functions as, again, the base for U.S. Scientific research, and has been doing this effectively for decades. And that's one of the reasons why it's so upsetting and disheartening to see mentions that it might be closed or become closed or change, because essentially it's been quietly doing a very good job, and we haven't needed another NCAR.
And just to clarify, I mean, this is, for folks who aren't as familiar, I mean, it's a research center, but it's also, I mean, this is a place that houses scores and scores of supercomputers, right? And when you talk about these data sets, you aren't talking about a single Excel spreadsheet. You're talking about just terabytes and terabytes of data, as you're pointing out, more than a single institution can handle. So, I mean, as you point to the fact that this stores decades of previous research, what really is the scale of what we're talking about in terms of if this data were unavailable, what would that mean to scientists who are trying to do this kind of work?
Yeah, if NCAR is dismantled, it would mean that we're losing critical weather and climate data. We're losing also kind of the highly skilled and trained scientists, engineers that support the use and also kind of the integration or assimilation of new data. NCAR also benefits like public safety, disaster preparedness, national security, human health. It also supports U.S. Government operations and research across all the other institutions. Like our whole academic system is set up to use this resource. So a loss of U.S. climate and weather data infrastructure would affect downstream not just scientists, but also folks that are in emergency management and like disaster preparedness. It affects kind of the aviation industry, is like all of the kind of information or simulations that we use to understand icing of planes was developed or run by NCAR. It also presents, it changes how the United States is maybe seen in kind of an international community as a leader on the front of climate modeling and climate prediction.
Are there other international leaders that are taking up some of that mantle?
There are, and they'll have to. People will find a way to make this, but it won't be because of the United States.
Yeah, and then I wanted to circle back actually to what you were saying about scientists having to do more equal amounts of work with less resources, because I've seen it up close personally. It's devastating when a project gets canceled, right? And so I'm curious, how do you think, both on an individual level for these scientists that are having their lives disrupted and on an organizational level, how is the scientific community adapting to these kind of new challenges? What are some of the choices and trade-offs that are being made to survive?
Yeah, that's a really good question. I mean, I think you can't do everything. You can't support everyone, and you can't. At a time when we need more climate research, more investment in resources to understand regionally how people are going to be affected by a warming world, we're taking money from the institutions that are and a really important piece of that research. By no means is NCAR the only. It is a center that is used by other. It is a tool that it can be used by other scientists across the U.S. and across the world. But we're essentially taking tools from our scientists to use when we should be giving tools to them to help understand a system that we still there's lots of uncertainty associated with climate system, climate change, and also uncertainty that we aim to understand itself, like intrinsic uncertainty that we need to know more about.
Yeah, I'm curious if you want to talk some about the impacts that the shifting landscape around funding, around facilities like NCAR and these other organizations, the fact that these facilities aren't available, the fact that grants aren't available directly impacts student learning. It directly impacts how the next generation of researchers, folks who are not that much younger, but a little bit younger than you, are coming up. And if you can talk a little bit about, are we looking at a potential deficit in researchers down the road? Are we looking at real roadblocks to students actually being able to continue studying and learning about all of these questions around meteorology and climatology as you're discussing?
Yeah, I think there's the impacts of something like NCAR being disrupted or broken apart, or also a program like USAP, the U.S. Antarctic Program, being defunded or funded less. You can't expect the same volume of researchers to come through and experience graduate education, to experience field work, to learn how to run these complicated models without supporting the infrastructure around them that enables all of that work. I think for students, I still think we have a lot of access that's to these fields of study, but we have to think creatively about what that looks like in a world without some of these important programs.
Yeah, and then this is like more of a personal question that I love to ask people, but as a student yourself, what was it that really got you into, climatology, meteorology, your ice work? What appealed to you about it?
Yeah, so I grew up in Eastern Washington, and not far from Hanford Reach, which is part of the Manhattan Project, but there has been a lot of environmental contamination associated with this project in particular, but then kind of the Manhattan Project more generally, and it was kind of being part of the downwind community that like first drew me to earth science. And then an experience in Alaska as part of a research opportunity for undergraduates where I first got to see a glacier, experience ice, and the science and the scientists who study ice. It was through that experience that I learned I wanted to do and become a glaciologist. So that experience wouldn't be possible without funding and support from programs like the National Science Foundation, which supports both of these. NCAR as a program is supported. It's a part of the National Science Foundation. So is the U.S. Antarctic Program.
Dr. Andrew Hoffman is postdoctoral research scientist of marine and polar geophysics at Columbia Climate School. Dr. Hoffman, thank you so much for joining us.
Yeah, thank you.
Thank you.
Now Antara will sit down with two local meteorologists to talk about the ways that federal cuts are impacting our local weather reports.
To better understand what weather forecasting is, how it works, and how it's changed in recent years, I sat down with two familiar faces of the Houston area, Justin Stapleton, broadcast meteorologist at KPRC2, and Travis Herzog, chief meteorologist at ABC 13 Houston. Mr. Stapleton, Mr. Herzog, welcome to the show. Could you start us off by introducing yourself and what it is you do?
Sure. Justin Stapleton. I'm a broadcast meteorologist at KPRC2, NBC affiliate here in Houston, Texas.
Yeah, my name's Travis Herzog, and I am the chief meteorologist at ABC 13 here in Houston, Texas. And My job is to lead a team of meteorologists to try to get the weather right over the next 10 days to predict what is going to happen, how it's going to impact the community that we serve, which involves all of Southeast Texas. And then during severe weather, our role is to provide life-saving information to help people make good, well-informed, wise decisions during bad weather to protect themselves, their families, and their property.
Could you tell me a little bit about how the flow of information works for public weather reporting? What has to happen at the national level, the state level, and the local level to get our daily weather forecast?
Yeah, it's a great question. So everything works in tandem. We'll start on the big picture and we'll kind of zoom down as we get into the local picture here. So the big picture starts with a lot of the federal government. This is from National Weather Service, from satellites that are operated by different countries in some spots, if it's more of global information that's coming in. The United States National Weather Service, NOAA, which is under the umbrella of NOAA, operates a number of different reporting stations, satellites, major computer systems that are all across the country. So that's the global spot. And then when you zoom down to a state and a local level, most of the major airports all have weather stations, and those weather stations are operated by the National Weather Service. So, for example, here in Southeast Texas, our National Weather Service office is located down in League City, so down 45 as you go down towards Galveston. That's where the main radar is that we use every day from a broadcast standpoint, and that folks can see on the National Weather Service website. And they all operate and maintain most of the reporting stations that are at all of the bigger airports. So Bush Intercontinental, Hobby, Ellington Field, Sugar Land Airport, Tomball, Galveston, Schollsfield down there on the island. And so these weather systems that they have, or weather stations, they're very large actually. They handle everything from temperature, pressure, sky conditions, measurable rain, precip, barometric pressure, all of these different parameters that are taken continuously throughout the 24-hour cycle. And so that information, along with the global satellites, gets pumped into either the local National Weather Service office, where we can pick up the data for what we use as our forecast as broadcast meteorologists. And that data goes into these big supercomputers that are owned and operated by the federal government. What their job is what they do is they take all of that real-time statistical data and they put it into these mathematical algorithms and equations. And that's where the computer modeling comes from. So the computer models come in, and then we as broadcast meteorologists take the real-time data, the global satellite data, and what the computer forecast statistics are showing. And then that's how we sort of put our forecast together. Sounds like it's a basically big sandwich, and it is. It's sort of like layers of a cake is probably the best way to think about it.
So how often are you receiving this data? Is it like daily? Is it weekly? How like kind of real time are these updates?
Depends on the data. If you're talking about just a forecast, like let's say, what is the high going to be today? What are the surface winds looking at? What is the barometric pressure? That all comes in almost continuously. I believe most of the reporting stations, if I'm not wrong, comes in every 10 minutes. Some are every 30 minutes. The computer modeling data we use generally comes in about 4 or 5 times throughout the day, because there's so much information and stuff that's put into these models. And these equations are, as you might expect, if you've ever taken differential equations or Calc 4 or something like that, they're like 12 lines long, right? So there's a lot of stuff that has to get crunched in that all gets spit out as this forecast. So it depends on what kind of data that you're looking for. But yeah, just in terms of what are we looking at over the next 6 hours, that can really be gleaned from all of these different airport sensor sites all across greater Southeast Texas here. And it's super valuable and important. Like, let's say if you have a big storm system coming in, if we have a hurricane, a tropical storm that's starting to move in from, the Gulf of Mexico, very important to make sure we know what real-time data is happening out there. And so that's really kind of our eyes and ears whenever we have big weather events come through.
A lot of that data depends on access to funding, which has been cut for a lot of scientific research in recent years. Could you talk to me a little bit about how these funding cuts might have affected meteorology and weather prediction?
You know what? It's a talker. It's a big talker in the weather world. I can tell you that it's something that we have talked to local representatives. We've talked to congressional representatives about the need for having the funding, that not only just the current funding that we have, but in addition, not having additional cuts to certain programs or plans that would leave us blind, so to speak, if you want to think of it that way, for things that are happening. I know one of the concerns that came up earlier this year when there was a lot of the staff cuts at the National Weather Service. The question was, well, are we going to miss storms or tornadoes, for example, or flooding events if there's nobody there at the station? And thankfully, the National Weather Service has done a good job of sort of stemming that tide. They've moved people from certain offices to other offices, which, obviously is an upheaval for the folks that are involved in that, just moving their lives. But they've been able to stabilize that to the point where we've not seen much of a hiccup in any of that coverage. Now, I will tell you, going into this summer's hurricane season, it is going to be very interesting because there was a satellite relay system that was set to expire, I want to say in February, and they pushed that back to 2027, knowing that if they're going to try to get funding and put something in place, we're going to need time to be able to do that. We can't just cut this off, because that would basically be like if you're looking through binoculars, taking one side of the binocular and just putting something up in front of it so that you can only see like this side when we need to see that side as well. So that was a big concern. It's something that I think it's a public safety issue. And my hope is, and I feel like pretty confident in this, that there are enough folks that understand that, well, yes, there are ways you can make some trimmings to that, that at the same point, need to have all eyes and ears and folks available to be able to provide accurate and timely forecasts, especially going into a hurricane season for all of the Gulf Coast states, not just for us here in Texas, but, from Florida all the way over to Mexico. It's a super, super important thing to have. So we're let me just say we're cautiously optimistic. There we go. So I'm trying to get that out. But as most things, we'll make adjustments if we need to. But yeah, we're hoping for the best and planning for alternatives if we need to.
I mean, that's all one can do, really. But pivoting slightly to you, Mr. Herzog, I understand that you've worked a lot on extreme weather, and most recently covered Beryl quite extensively. So I'm curious if you have any thoughts on how these funding considerations may affect extreme weather reporting more specifically.
Yeah, the U.S. government puts a lot of resources, a lot of taxpayer dollars into weather prediction and forecasting, and it has shown that it has paid off dramatically. For each dollar invested, you're getting like a $10 return on investment by what's saved through just economic activity alone. So a year ago, we were in a really precarious situation with all of the DOGE activities that were going on at the federal level, the cuts that were happening in real time, the proposals that were being made to cut things even more. And we're still seeing proposals for significant deep cuts to scientific research across the board, but including in the world of meteorology. And it would absolutely devastate our ability and handicap us to be able to make further advancements if those were to go through. It's expensive. It does cost a lot of money to be able to launch weather balloons every day, to operate these radar networks, to fund the National Weather Service, the National Hurricane Center, the Storm Prediction Center. But overall, the federal weather enterprise is a very lean, well-oiled machine that is high performing and does a lot of great work that helps save lives, helps save property, and reduce losses of economic activity. So I think personally, it's money that is very well spent with the resources that we put into making those accurate forecasts. The good news is that things have kind of turned around over the last year. A lot of the proposed cuts have gone away. Congress said, no, we need to fund these things. The one thing that lingers, though, of what's happened over the last year is we had a tremendous loss of institutional knowledge and a large brain drain of older meteorologists that were maybe several years out from retirement, taking these retirement packages early, these early retirement packages. And so we've seen a lot of very well-seasoned meteorologists that have left. And so you've got new meteorologists coming in, but meteorology is something that takes a lot of time and experience and knowledge to really to gain and grow as a forecaster, as a researcher. And so anytime you lose someone that's got 3-4 decades of experience, it's definitely a blow because they can't then pass that information along, the things that they've learned to the younger generations that are coming in. And so in some ways, some of these newer forecasters are having to learn things the hard way through trial error, blowing a forecast and learning from it. And some of that pain could have been saved if we were able to hold on to those folks a little bit longer.
And then you mentioned, I think, the National Weather Service. There's also the National Oceanic Atmospheric Administration, FEMA, the Federal Emergency Management Agency. So when these headlines come up that, there's proposals for cuts and there's been layoffs and whatever, what does that actually look like? What are we losing in those processes?
Well, when it comes to cuts to the National Weather Service resources, the ability to collect data that makes the forecast more accurate, the result ends up being less accurate forecast. And there was a time last year where we had big holes in our weather balloon observation network. And so that degrades accuracy. And so it's really important that we have that data to be able to produce the most accurate forecasts that we are able to. When it comes to things like cuts to FEMA, that's more emergency management territory outside the realm of meteorology. It's dealing with the aftermath of weather events or other natural hazards, natural disasters. But from what I hear from the emergency management community, proposed cuts that have been out there would absolutely devastate smaller communities and less funded states because they'd be left to foot the bill that they haven't planned for over the years because they've been used to receiving that help and assistance from the federal government, who has far more resources than these small towns and other smaller states that aren't as well funded as a larger state, say like Texas or California, Florida, New York. And so, at the end of the day, these cuts, what they really mean is that impacts to people. They end up hurting people because people don't get the most accurate forecast and they don't get the help to recover that they need in the wake of these natural disasters. These kind of safety nets we've built into our system over the past several decades. And when you finally kind of pull that out, it's like pulling the rug out from underneath someone. And now you're in a much different situation.
Mr. Stapleton, I wanted to circle back to the National Weather Service, which you mentioned at the very start.
Sure.
As far as I know, weather reporting has remained somewhat of a public good. Has there been any move towards privatizing weather reporting or making this less of a governmental or legislative issue?
Yeah, that's a great question. There are private companies now that do forecasting. There are private companies that have their own meteorological staff. Like the Houston Rodeo has their own staff, by the way. And they work in tandem with the Weather Service, but oil and gas companies, transatlantic shipping companies, sports, right? Houston Texans have their own weather people. So yeah, I think it is that way. I don't think that it will ever go away just because there are so many different areas that maybe don't have the financial capability to create a private forecast. And part of that is it's just for the greater good. So while I do think that there is a push sometimes for privatization of the National Weather Service, I'd be hesitant to see that would happen. It may happen 20 years, 40 years down the road, but in terms of like the near term, next 10 years, I just don't think that that's going to happen. I don't think that's a bad thing to have, privatization of certain forecast products, for example, and skills. But I do think that something that is a public need and a public safety issue has to be freely available to the entire public 24/7 when they need it, right? I mean, our tax dollars are paying for all of this information, yours and mine. And so that's why everybody should have access to it and should be free to use it.
Now, we wouldn't be having a conversation in the year of 2026 if we didn't mention AI at least once. So I'm curious, considering both of you come from backgrounds of extensive scientific training yourselves, how do you feel about AI applications in the meteorology space? Are you optimistic? Is it not where it needs to be yet? Is it already being used at a large scale? What does that kind of look like as of now?
Sure. Well, I'll speak to two different components that I've looked at when it comes to AI. One is in predicting hurricanes. And last year, the National Hurricane Center started using Google's DeepMind AI model for their hurricane predictions. And they referenced it many times in their discussions throughout the season, saying that it was showing this solution and they were kind of tilting the forecast in that direction. And after every hurricane season, they do a post analysis to see which forecasts were the most accurate, which models performed the best, both for each individual storm and also collectively over the entire season. And what they found is that Google's DeepMind AI model was the best model, even better than the National Hurricane Center at many timescales in its forecasting. So it did remarkably well. On the intensity side, it doesn't do as good, but this season they did a lot better because of some enhancements they made to the model. So I believe that these models will continue to improve and be very useful in certain applications like the prediction of where hurricanes will go, how strong they will be when they pass over certain water basins and land masses. And so I'm excited about the potential for that. It's also been used to predict and extend the prediction timescale of the what's called the El Nino Southern Oscillation, or ENSO, El Nino, La Nina, and the in-between phase when it's neutral. And so there have been models that have been developed that that are able to determine up to 18 months in advance how that's going to transpire, and they've gotten a lot better in the accuracy. And that's important because it impacts what's happening around the globe as it shifts the jet stream weather patterns. So that can help with long-term planning for farming communities, knowing that they're either going to experience more drought or more rainfall. And so that's also a very useful application of AI models. And then also, just in everyday general weather forecasting, the AI models are making significant progress there as well, pretty rapidly at being on par with their accuracy with what we are observing with our more advanced models that are powered by supercomputers. Now, those models, what we call dynamic models, that you often hear us talk about, like the American GFS model, the European ECM model, those use very advanced physics and take a lot of computing resources to produce their forecast. That's the starting base for the AI models. So the AI models are taking the initial conditions that those models interpolate and then is basing its forecast off of that. And because of the way it's designed, it only takes a matter of minutes to produce a 10 to 15 day forecast on the AI side, but it would not be possible without the more sophisticated, slower number crunching, or more. It's not that they're crunching the numbers slower; it just takes a lot longer to produce the data because of the sheer volume of mathematical equations they're producing. So the two are kind of working in conjunction, and we're still trying to figure out the strengths and weaknesses of these models. They're so new to the scene, just a few years, and as the models are tweaked over time, they almost become entirely different models, and so you have to relearn their biases. And so that's something that we're always looking at, is which model performed best in certain situations, and then can we trust that model in future situations to perform similarly?
Now, we might as well bring up the second hot topic of the moment, climate change. In the past, we've had a bit of a climate-weather binary and have imagined them to be quite distinct. As climate issues intensify and start to have effects on a shorter time scale, do you think the lines have blurred at all? As someone in weather, do you feel any sort of interest or responsibility towards looking at climate change?
Yeah, I think so. I think because it's what we're seeing in terms of the weather is becoming more extreme because of the climate. And so, yes, I think morally responsible, just from an individual standpoint, from a Justin standpoint, I find it very important to make sure I let people know that this is something that they need to pay attention to, right? I always say this when I do school visits, and I tell people to say, science will happen whether you believe it or not. It doesn't matter, right? So what can we do to help all of us get through that? And I understand, take the politics out, and aside from that, that's not really a lane that I like to get into. But it affects everyone. So I try to sprinkle as best I can without trying to cause a ruckus to say, these events that we see on a daily basis, or even in a summary basis, let's use a tropical example, these are getting more extreme on the cold end and on the warm end, on the moisture end, on the dry end, right? Droughts are getting bigger and stronger. Tropical systems are getting bigger and stronger. Tropical seasons are getting longer. Winters are getting shorter. Summers are getting longer, right? Like, these are all undeniable facts because we have the data to show that in the atmospheric research and the climate research. So what we're trying to do now, we're trying to figure out now is, what does that mean? What do we need to do to adapt, right? Like, a lot of the systems and things we're using were made for a world and a climate that doesn't exist anymore. And so we have to adapt to that, right? Like, we're running in the 20th century, but we're in the 21st century climate. And so we need to catch up to the 21st century technology and ways of thinking about what we do going forward.
Obviously, every professional kind of has their own take on the field they're in and what it should be focusing on, what the future trajectory might look like. I'm curious, as someone who's been working in Texas, if not Houston, for pretty much all your career, if I'm correct.
Pretty much, yeah. Texas my entire career, and Houston, the vast majority of it. It's been about 20 years in Houston this summer.
20 years. Wow,
Yeah.
incredible. And so, based on all that experience, are there any trends that you think have become more prominent or things that we've kind of over the past 20 years have begun to pay more attention to? And as an extension of that, is there anything in the next, years you think Houston meteorology is going to have to emphasize more, look at more?
Well, I think that the forecasts have definitely improved significantly over the 20 plus years that I've been a meteorologist. So we've definitely seen great improvements in accuracy. It's more noticeable now when we're wrong because we're right so often. As an example of just how much forecasts have improved, if you were to take a hurricane forecast from 1980 and compare it to a forecast from today, today's forecast 5 days out into the future is as accurate as the 1 day forecast was in 1980. So we've gained 4 extra days of accuracy, for hurricanes alone. So we've definitely seen massive improvements there. We've also seen a lot of changes to how the weather is impacting us here in Houston specifically. We've seen the intensity of the floods that have been coming our way since 2015, how the heat is getting worse over time, how the droughts are coming on quicker. So we're definitely feeling the impacts of that changing climate and how that has influenced our local weather patterns and what we can expect on a yearly basis. I've also noticed just that there's a lot more interest in the weather. We're more connected as a society now, but with that, a lot of bad information spreads very easily. And we have seen a proliferation of conspiracies related to weather control, weather manipulation, things that just scientifically we can't do. People claim we can do, and we just can't. And so there's been a lot of disinformation, misinformation that we've seen spread. And we're seeing a lot of that happen as well with the proliferation of weather data in the social media space, where someone whose primary concern is getting paid, so they're going to put out something that's just outrageous, that's 2 weeks into the future, and people start to think, oh my gosh, this big hurricane's coming. This model showed it 2 weeks from now. When a meteorologist that's been studying this all their life knows you can't trust that model. The very next model run is going to be wrong or is going to show something completely different. And but they're not going to post that. They're just going to post the one that shows a massive hurricane hitting Houston 2 weeks from now. And so my hope is that in the decades to come, forecasts will continue to improve in accuracy. Our role as meteorologists will be focusing more and more on just communicating the impacts of what the weather will do as we gain confidence in being able to figure out the weather with greater accuracy over time, and also that the educational literacy, weather literacy, and just awareness will increase among the entire population about who to trust and who not to trust when it comes to all the information that's available out there. That trusted voices will rise up more and more, and that people will gravitate towards those trusted voices instead of the people that are just kind of engagement farming, trying to make a buck playing off of your emotions about some scary weather event that's likely never going to happen.
For the final question, because I know I've taken up quite a bit of your time,
Oh, it's
I'm
fine.
going to make a very arrogant assumption and say that there's people tuning into the podcast that don't watch the weather. What would you kind of want them to take away or keep in mind regarding weather now and maybe in the next couple of months as we move into summer?
Sure. Well, first off, I realize that it's very easy to get a forecast anywhere. There's a multitude of apps out there. You look at your phone, think you're good to go. But what I will say is that there is a role that a local TV meteorologist plays that your app and the data can't give you, and that is whenever there's severe weather. It's very important that you turn into a trusted human that can actually guide you through that weather situation to help you make potentially life-saving decisions in that moment. And so we're here for you whenever you need us. Okay, whenever the weather goes crazy, when that extreme weather hits, we are here to guide you through that storm. I get it. You may not want to watch local news on a regular basis, but we are here for you when those rough storms come on through. And that is one of the public services that we provide as a local broadcast TV station. And so we are here for you. We are now in the thick of the spring severe weather season, and hurricane season is rapidly approaching. Every hurricane season, we encourage everyone to prepare the same because we don't know whether or not we're going to get hit. What I will say is that we have what's called an El Nino in the Pacific Ocean that looks to be coming on very strong, potentially one of the strongest we've observed in over 100 years. And so El Niños typically reduce the tropical activity in the Western Gulf. In fact, going back to 1950, when we've had El Nino active, there has not been a single hurricane that has made landfall in Texas and only a minimal number of tropical storms. So we can still be impacted by tropical weather systems in an El Nino, but it's less likely this coming hurricane season. Am I still going to pay my flood insurance and my home insurance? Absolutely. Am I still going to prepare as if there could be a hurricane? Absolutely, because again, we just don't know. And there's always these outliers that can occur that kind of buck the historical trend. As far as severe weather goes, we're also entering the peak of our spring flood season. That's the most common natural disaster that we experience here in Southeast Texas. We have very flat land and we get extremely heavy rainfall. And because of the flat land, it takes a long time for that water to drain. It's a different kind of hazard, say, in the hill country, as we found out last summer with the tragic hill country floods due to their more hilly, mountainous terrain. Those floodwaters rapidly move through, and they can see incredibly high rises in a short period of time. We have more gradual rises, and it's more of a street flooding problem. It's more your engine's going to get drowned out, or you might get a few inches of water into your home. We're entering that season. But I jokingly say that severe weather and flood season in Houston starts on January 1st and ends on December 31st. We can have bad weather any time of the year. Floods, severe storms can happen any time of the year. Hurricanes do have a very specific season, and for us, the impact in Texas is usually from about June to October. That's kind of our tropical storm hurricane season. But year-round, we can get bad weather. So I always encourage people to at least have a general awareness of what the weather is expected to do over the next several days, especially as we get into hurricane season and things can change pretty rapidly with these rapidly intensifying storms we've observed over the last decade. And of course, we're entering the summer heat. It's important to try to get your body acclimated. Anytime it gets warm outside, spend some time outside for a few minutes so your body can start adjusting. And we'll just hope that we don't have a brutally hot summer ahead, given the drought conditions that we still have present in Southeast Texas.
Well, that's all I have for you. Thank you so much for taking out the time to talk to me. I appreciate it so much.
Thank you. Thank you very much. I really appreciate it. It's fun talking to you.
That's our show for this week. If you have questions or ideas for what you'd like featured on Gulf Streams, leave a voicemail at 713-348-4081 or email us at westonT@rice.edu. A quick reminder that you can catch up on Gulf Streams anytime through our podcast, available on all major podcast platforms. If you enjoy the show, please like and subscribe to make sure you never miss an episode. Gulf Streams is a co-production of KPFT Houston and Rice's Center for Environmental Studies and the Rice Sustainability Institute's Eco Studio, produced by Weston Twardowski. Original music by Carter Dean. Research support provided by Sarah Tabrez and Antara Barma. Stay tuned for No Expectations of Marcus French here on KPFT Houston 90.1 FM, Galveston 89.5 FM, and Huntsville 89.7 FM.